Hello, this is Susan Ploss. This is a system to be solved by graphing that one of my students sent to me. You can see it's a fairly complicated system because it's got all these fractions in it. The first thing you want to do is take each equation and put it into slope-intercept form so you can identify the y-intercept, and also you'll be able to identify the slope. But let me tell you something that I'm noticing, just to give you a hint as you start to look at these. I'm noticing that this, hold on, I'm noticing a mistake over here too, equation number 2. I'm noticing that if you take equation number 1 and double it, you're going to have the x coordinate, the x term in equation number 2. And I'm also noticing that this 4/5 over here, if I double it, it's going to take me to that 8/5. So I'm guessing that something unusual is going on here. It's already looking to me like the second equation is just double the first equation. That should alert you that something unusual is happening. All right, so down beneath here, you see where I've written equation number 1 and equation number 2, and I've already moved the x term in each of these over to the right, and of course the sign reversed as I did that. So the way you want to go about isolating and getting a positive 1y in this spot is to take each term in this equation, and I'm going to multiply by the reciprocal of -3/10, because I'm trying to get a 1 in this spot right here. I want that coefficient on the y term to be 1. If I multiply by the reciprocal, I'm going to get a 1 in that spot. However, when I multiply by -3/10 there, I have to also multiply by -10 on the x term, and I also multiply by -10 on the constant. And when I do that last multiplication out there, looks like 40 over 15. Oh, I didn't see that 5. I could have done some cancellation there. So let me go ahead and reduce that down using 5. Okay, so I can see that the y-intercept is at -8/3, and I can see that the slope is -10/3. That's going to be messy to graph, but let's go ahead and continue on. So in the second equation, I've already moved the -2x over to the right, and I'm going to take this equation, and in order to create a situation where I have a positive 1y, I'm going to take the entire equation and multiply it by -5/3, and again, the reason I'm doing that is to get those two numbers to multiply to give me a positive 1. And again, I've got to remember that that -5/3 gets distributed throughout the entire equation. So I'm seeing a -10/3 x here, and I'll go ahead and work this part out. I did something in my head there maybe I shouldn't have. I'll go back and show you that step. Now I'm noticing that those 5s are going to cancel out when I missed it before. Let me show you how I got here. I took the, when I multiplied the 2 by the -5/3, let me squeeze it in right here. Whoops, sorry. That's where I got the -10/3 right there. So I'm noticing something really unusual here. Notice that the slope on this line is also -10/3, which was, here, I'll show you this. This slope is -10/3. This slope is -10/3. So maybe they're parallel lines because they have the same slope. Then I go on out and I look at the y-intercept, and oh my goodness, there is something unusual going on here. The y-intercept is the same. So even though these equations look different to start with, what I have here is the same line. So I have one line that would graph on top of the other line, because they are the same line, equation number 1 and equation number 2. So this is one where you have infinitely many solutions. Hope that helps, Precious.